I would love to introduce you guys to our very first speaker, Gavin. Gavin, his talk today is called Testing, Gotta Get Down on Testing. Very creative, love it. So Gavin, if you could please make your way to the stage while I introduce you. Gavin is a professionally employed software developer for more than 20 years now. He has had all kinds of experiences in all kinds of projects, open source, meetup, companies, etc. He's here today to share his learnings on testing in general. So please help me welcome Gavin to the stage.
So, as mentioned, I'm Gavin. I'm a senior software developer at DigitalOcean. Currently on the billing team, which means I don't really get to do JavaScript anymore. But I figured I still have enough old JavaScript knowledge that I can probably come up and talk about testing, because testing is pretty universal. But I am going to try, and I'm stressed here, try to bring this back to JavaScript. Okay, so what am I here to talk about? Well, Merriam-Webster defines testing as a means of testing. Okay, just kidding. I'm not only that really confusing definition, but I'm not going to do a high school presentation style. I am going to just generally go into testing. So why should you listen to me? Well, I mean, there's something for being up here speaking in front of all of you, right? So while I don't have the expert knowledge, I'm not paid big bucks to be a tester and a big contractor or a consultant, I have broken a lot of things in my career. In fact, I like to pretend I'm the first person to break things, so then I know how to fix it. And then when people come to me, you can go, oh, cool, I know how to fix it because I broke it last week. I've also worked at a bunch of SaaS companies specifically targeting testing products. So that includes SaaS products, that includes on-premise products, that includes frameworks. So I have been exposed to a lot of different techniques. But generally, it's just one of the things that I found makes my life easier as a developer, so I'm sharing about it. Okay, so testing, what is it good for? Other than to urge to start thinking about war and what it's good for, which is probably not the best topic right now, what is it good for? So one of the nice things, like out of the box things about testing is it's good for living documentation. So a lot of the times your code base will be out of date pretty quickly. Your comment will be from a year ago, you forgot to update it. Or your Confluence page is just out of date. So testing is nice because it's living up-to-date documentation on how your functionality works, right? You can see what the inputs are, you can see what the outputs are, you can see what the expected behaviors are. So if a week from now someone changes how login button works, you now can see how it's supposed to work in the first place. I find it really nice for coming into projects for the first time. You can now see how everything works. It also is really big on confidence. So one of the talks last month brought up the fact that AI, which as it is everywhere now, can actually use your various testing to help produce code that is actually fitting your code style, your application. Because a lot of vibe coding and all the other tools right now are just pumping out code. Who knows if it's relevant to your product or not? I also find it's very good for bug tickets, and that's usually one thing I will bring up later. But I find one of the best ways to get started is to take that bug ticket that came in and said, hey, this thing doesn't work. You start writing a test right away to figure out how or what it is doing, and then what it's supposed to do. So now you understand the problem, and now you can try to fix it. It saves you time and stressing out about trying to figure out how it worked in the first place. Okay, so what is testing? I couldn't find a good definition of what is testing. At one point in time, there was like textbooks on the pyramid on what you're supposed to do, but now I can't find any of that. So I did find this practical test pyramid by Martin Fowler, which is essentially what I'm thinking of. The idea is that you should have the most fast tests and the least slow tests, right? Which kind of makes sense. So my testing pyramid, and I forgot to actually draw it out because I draw really good, is end-to-end tests, mock tests, and simple tests. So you want as many as you can simple tests and as least as you can as the end-to-end tests, because they are the slowest and hardest to work with. So end-to-end tests. That's the concept of everything's real. So you're going to use a real browser. You're going to use real servers, real credentials. To some degree, test on production if you can, but you want to do as much as you can real active stuff to make sure that your whole system works, right? So if someone goes in and deactivates your Stripe account, all of a sudden you find out because your actual end-to-end test will confirm that. There is kind of a fuzzy room in there, so some people think that you should test on the other extreme and just have like replication of production and test in isolation. But I think if you're going to spend all the time and energy to try to make these somewhat flaky tests work, you want to test the real thing. So some of the strengths about end-to-end tests is that it makes sure everything works together. So, in modern web applications, you're going to have your front end, you're going to have your back end, you're going to have components, you're going to have external marketing tools, you're going to have all the different pieces, and it's very easy for them to break and not talk to each other. Like, very easy. In fact, I would spend probably most of my day fixing one more external system that stopped working. So that's the one good thing about end-to-end test is you're testing the whole thing end-to-end. It also is the closest to end user behavior. So, if that browser doesn't do one behavior you think it does, because on your computer it's fast, but on the actual internet it's slow, this can catch those things. It's also really good if a vendor changes some behavior or a script or it stops loading or goes under and stops working at all. These are the tools this kind of testing is really good for. Weaknesses. So when you're doing everything with real behaviors, it's really hard to specify. What did I say? It's really hard to create or reset states. So it's really hard to, for example, create a user with a shopping cart that had an existing shopping cart already there, right? You can easily go in and make a new shopping cart, but you can't set up legacy data. So you can't test to see what happens if you have a 2-year-old profile. You can't see what happens if, whatever data is. You essentially have to do everything by hand. Now, there are workarounds. You can start writing, back-end private APIs to work around this. But then you start working around actually doing end-to-end tests. You might as well be doing other tests in that case. It's also the slowest because you're actually using browsers and you're actually saying, hey, or when I say browsers, I do mean any tooling. But when you use a browser, you're actually telling it to do something. So a browser is going to be set up for a human to interact with it. So it's going to have like interactions, it's going to have delays, it's going to have like click actions. All those take time. Whether that's 300 milliseconds, it still takes time. While other tests can be run instantaneously because they don't have to wait for anything. And then flaky, one reason I really despise end-to-end tests is how often they break because someone changed a letter. So it was like a capital R, and now it's a lowercase r, and all your tests break. Someone just thought, oh, it'd be cool if I move this button over, and now everything breaks. So they have a tendency to break really easily. There are techniques and tools to make them more robust and safe and secure, but you get what you get. So end-to-end tools. Throughout the slides, I do have a bunch of tools. I'm doing my best to remember what I have used in the past and what exists, but I'm by far not an expert. So I would suspect there's at least one person here who will tell me that these are the wrong tools. But honestly, if they work, they're the right tools for you. So I will say Selenium is probably the biggest name on here. It's been around for at least 15 or 20 years. It's been around forever. It's one of the oldest techniques for automating your browser. It works. I wouldn't say it works well, but it works. Playwright and Cypress are much more modern versions of the same tool. They have a tendency, or they are backed by actual browser developers, so like Microsoft and Google actually contribute code to it, so it tends to work more reliably. It tends to work faster. It tends to actually have a faster connection, so you don't wait as long. And then I learned about Test Cafe from researching here. It apparently can pretty much run on anything that can run JavaScript. So that means smart TVs, that means 10-year-old phones, that means someone else's browser. Like, it's a way to automate your browser from inside the browser. So you're not remotely controlling a browser, you're actually running a script inside your browser. So it looks like it's a pretty cool tool. I haven't used it myself. And then we have Appium. Appium was created by a couple of friends of mine, and it's gotten really big. It lets you automate mobile devices. So if you want to install like an actual standalone app, you can install it and click on different things and everything like that. Okay. Mocked end-to-end tests. So this is the area where I tend to spend most of my time in. I'm not sure how many people here are going to be doing as much back-end work as I do, but in general, it's a little bit nice. It's a little bit, it's in between pure functional unit tests and end-to-end tests. So I tend to say you want to mock out the things that you, what did I say? You mock out the things that are external to systems. So in this case, Stripe, or in this case, Google Analytics, something that you don't maintain, but there is a contract that says this is how it's going to work. That way, if something goes down, or you can control it, even to some degrees, you might want to use some of your own backends and mock them out to return values that you can control to make your tests still do some complete functionality tests, but not start from scratch every time, not have to hit that login button, not have to hit that buy button every single time to get anywhere. The problem with mocks in general is I think everyone who gets started with testing eventually starts building mocks so complicated that you end up testing your mocks and not your code that's using the mocks. I would say that's a guarantee in life, and one day it will happen to you and you go, I shouldn't do that. I'm going to stop. But it is really easy to spot new dependencies, right? So if you have a new component that is now talking to the database you didn't realize before, your test will start failing. And you'll be like, oh, I got to actually add a database mock, right? It's very clear to see why you're doing this new behavior. Some of the cons, as I said, you'll eventually have to implement your own mocks. There is a danger that if someone starts returning new data from an external system or database or anything else, and it changes the shape, so instead of it being an integer, now it's a string, your code could break and you never notice that behavior. So generally, I still think it's a good practice to have mocked integration tests, but you got to kind of balance it out. There are a lot of tools out there for mocking. Knock is one of my favorites. Apparently, it's still really big. It's really nice. It lets you emulate HTTP calls. So you can actually say, whenever I make a call to Stripe, return this string. So you don't have to actually go into your code and put in mocks. You just say, whenever this goes out, come back in. The nice thing about that is if your code is start talking to a new service, it will yell at you. You can turn it off. I don't recommend doing it because it saved me many times where I go, why is this test failing? Oh, it's because I'm now talking to this live service, Jest and sign-on have been around for a while. Jest is a big one. I will talk about that a bit more. But sign-on is a very powerful mocking library that's been around for a long time, and you can make nice mocks that return things. You can say it returns this value once, this value twice, anything else you want. And then the one that I learned about this week is mock service worker, which is essentially knock, but for your browser. So you can actually intercept all your HTTP calls, but in your browser. So you can actually do like React testing and everything else, but actually prevent it from doing calls to your backend or other services. So I'm excited to play with that one day, but I haven't had a chance yet. So unit tests. Unit tests is going to be where you want to spend your most time, right? You want a very fast, small test. They test one thing, they take some input, they check some output. That's what they do. So good examples of those are like sum functions, anything that manipulates data to make sure it comes back correctly, converting data between one system and another. So like a form post versus a database entry, or something like an input field or a string, or in this case, a password string component in React, right? It does one thing. It's not the whole component. It's just one thing. As mentioned, they're very fast. You want to get focused on writing them as fast as possible. But the nice thing is once you start writing unit tests, you start seeing this in your code design, because now instead of having this big complicated function that does 12 things, you start running functions that do one thing and you start sticking the 12 together. So now you have 12 different unit tests testing 12 different functionalities that you later go in and make sure they work together in integration. Which means you now have functions that are easy to understand when someone new comes in, or when you need to look at it tomorrow, or when you need to get paged in the middle of the night. You don't know how something works. Now that you've written them small, they're much easier to understand. The big cons is that if you do unit tests, again, they will break if external systems change and you don't know about it. With advent of TypeScript and Golang and even the new typed Python, it becomes less of a concern, but it is still a concern, right? So if an external system does change, you don't notice it, you won't notice. Yeah, running out of time here. So Jest, again, we got the nice standard tools, Jest, Mocha, and Jasmine. They've been around for a while. They're all work almost identical. In fact, I tried thinking about it. I think every one of these work almost identically. Okay, so I'm gonna try to get through this last little bit as quickly as possible. I will point out, because I forgot to mention earlier, all my slides are public on my website. So if I go over anything too fast, you can come back and look at them or come talk to me about it. So how to get started with testing. The key thing is, I don't think you necessarily need to get started with a test framework. My very first job was working live on production client systems. You would log in, you would do changes. You hope it wouldn't take down the entire company while you were doing changes, and then you log out. So I got in very quickly in the habit of bringing that one function I was working on to my own computer, writing a test script, making sure it worked, and shipping it and putting it back. Right? That's testing. It doesn't have to be a formal framework. You know, and you don't need to start by testing everything. You can just get started by testing one thing, which is why I always recommend testing with bug reports. One bug report comes in, you can't figure out how to fix it, create a test for it, and then you kind of understand how it's happening, and you might be able to figure out how to fix it. But the best part is you can actually guarantee that that very specific bug won't happen again. Something similar might, but that specific one won't happen again. Yeah, well, I covered that. So how do you actually get started? I'm definitely over time. I'm sorry. In the case of in JavaScript and Jest, it's really easy. You just do npm install Jest. Then you create a test file. So in this case, you have a function. You give a description. So in this case, to add 1 plus 2 to equal 3. Then you confirm that's the result. Like, this is simply describe your test, do an action, check to see the results, right? Then you run your test and you get results. So as you start building up that library, instead of it being one test with one success, you start having 120 tests with 120 successes. You go change one function, you can isolate exactly where that problem happened. You can go back and look. I'm going to skip over this one, but there are various tools to run tests for you. I just really wanted to show off, if you're using GitHub or GitLab, you can actually run your tests automated really quickly, really easily. This took me about 5 minutes to set up, and I do have an example repo there, but it just runs that Jest test, the same one I just had up there. Yeah, I'm going to call it there. So I did have a few more slides, but if anyone wants to catch up on anything I skipped over, you can go to the website and look at the presentations, and you can get a copy of all these, including speaker notes and everything else. Do I have time for any questions? Okay. Do you want to, Matt? Maybe? Do you want me to go
If
over?
anybody has any questions, I can run around with mine.
Thank you for the presentation. I just have a question too. I think, like the first one is how you measure which functionality do you want to cover with end-to-end testing and which not, because it's actually expensive to write everything, and maybe some tests can be flaky. So that's the first question, and the second question is how you measure coverage of end-to-end testing.
I have a long and opinionated opinion on coverage. I will say, working backwards in your question, I think coverage reports is really nice. So it's coverage reports are essentially a tool that runs through your code and says, is this line of code tested or not? No, sorry, I gotta be careful. Does this line of code go through your test or not? It doesn't say whether it works or anything else. It just tells you if your test has touched it. So it is very good as a local development tool for you to see what has been tested and what hasn't. It's very bad as a metric supporting tool from executive levels to say whether or not you have any tests. So
So I mean for end-to-end testing, not for unit testing.
Well, the same thing. I mean, a lot of the end-to-end tools will have some sort of coverage report tools. I don't write coverage end-to-end tests myself because they're not really that big on the back end, which is what I'm doing. They tend to be a little bit more on the user-facing side. So I don't know the specific tools, but there are tools out there that you can hook up to your live running production, and it can say what ones have been hit and what haven't been hit.
Okay.
And we got another question down here.
Just one more, please.
You mentioned a couple of languages. My question is, do you have a take on an approach to testing React?
I do. I'm less familiar with that in that space. It's been a while. There is the React testing React testing library, which is really good at that, so you can actually render your component. And I did want to talk about it, but specifically you want to make sure that your components don't do side effects, and then you can test really easily, and then you put them together as a bigger test later down the road.